Welcome back, friends. So now we have come to a stage where we are able to understand by seeing the function, whether it is an increasing function or a decreasing function, by applying the rules that we learned, like f dash x. If it is increasing greater than 0, then the function is said to be increasing. And finally, it reaches, let us say by chance, it reaches within the domain, a maxima point. Then at the point of maxima, f dash x we defined as 0. Once the maxima is crossed, we will be reaching to the function is continuing, let us say, then it may reach another minima or maxima depending upon the values of f dash x and other say points of interest. Now, after learning in a previous class about the second derivative test and then first derivative test to identify the critical points. Critical points are only the points where the function either reaches maxima or a minima or point of inflection. Okay, these three will be obtained by first differentiating the function and then equating it to 0. When you equate the function to after differentiation to 0, you will be getting f dash x is equal to 0 and then x values will come. These x values, we will use them for checking in the second derivative of the function to know whether we are getting a maximum or a minimum. If the second derivative becomes negative by chance or less than 0, after putting this critical point in the second derivative, then we will conclude that we are reaching the maximum. Or if it is, let us say, becoming positive by putting the critical point in the second derivative, then we will say that we are reaching the minimum. If the f dash x, which is actually the one which is deciding all this, if while crossing from the maximum region to the maximum point onto the minimum region, this sign of f dash x will change. If f dash x is, let us say, positive in the one direction, in other direction after crossing the maxima or a minimal points, that sign should change. F dash x should be negative or positive around this neighborhood of the maxima and minima. If this is not happening, if f dash x is continuing to possess the same sign even after crossing this critical point, then that point is said to be point of inflection, where the curvature will be changing. Either it will become upward or downward. Concave function we call. So if the face of the function is becoming upward concave or downward concave, f dash x will accordingly change the sign. This anyway, it is not much worried to remember right now, but right now we will carry out some sums to again understand thoroughly how to find out the maxima and minima of a given function. Okay, let us go to the whiteboard. Yeah. Now, first let us understand first sum. Yesterday's sum, I am just revising here. F of x is equal to x square. X belongs to set of real numbers. Find maxima, minima. Okay, of this function. Now, we know very well f of x is equal to x square is a parabola like this. This is origin and it is positive. This side and this side, the y values, f of x is always positive in this. That point we should remember. In all the intervals, it is positive. So here what I do is for all x, I'm solving this. For all x belonging to real numbers, f of x is positive. First point we should write this. Next point is we'll differentiate this. Our idea is to check the critical points. F dash x is equal to 2x. Why? F of x is equal to 2x, x square. Therefore, f dash x is equal to 2x. For finding out the critical point, what we are doing? We are equating the f dash x to 0. If f dash x is equal to 0, then 2x should be equal to 0. Then x is equal to 0. That means at x is equal to 0, f of x has minimum. Okay. Then f of x has a minimum value which is equal to 0, 0 square 0. Now, is there any maximum point for this? That we'll check now. Since f of x is equal to x square is strictly increasing, it is strictly increasing. Observe now, there is no end limit. It is going on. As you proceed with the x arguments either side, the function grows. We have not defined any interval here other than giving that x belongs to set of real numbers. Set of real numbers interval is minus infinity to plus infinity. So if you want to see what is r, it starts from minus infinity, goes to plus infinity. In between 1 0 you put both sides, it is like this. So in such an interval, if you want to check function's maximum value, it is, I will say it's not defined right now. Fully it is extending up to the minus infinity. At the extremes it may have, which we cannot define right now here. Therefore, fx has no maximum as such in the given value. Suppose if I restrict the domain, let us I gave a domain. If domain is given, let us say domain is given -2, 1. -2, 1 means what? My interval will start, let us say -2 here. This is -1 like that. This is 0, 1. So -2 to 1. This is the interval. So -2, -1, 0, 1. All these values belong to this interval. Okay. So this domain is having at -2, correspondingly, this is the y value. What is this value? It will be 4. -2 whole square will become 4. So that time fx is having maximum. Fx has maxima at x is equal to -2. X is equal to -2. That value is 4. F of -2 is equal to 4. So if the domain is restricted, you will have a value. Else it is strictly increasing, but minimum value is there. That is x is equal to 0. Understood or not? Next, let us go to the second sum. Second sum, let us take this function. F of x is equal to mod x. Here again, x belongs to, let us say, set of real number. This function looks like this. Understood, no? This is f of x. This is x, x dash, and f dash. This y dash you can write here, or f dash x you can write, no problem. You leave it here. Our function remains like this now. This is negative x, y axis. So what is fx is equal to mod x means? Fx is equal to minus x as long as x is less than 0. 0 at x is equal to 0. X when x is greater than 0. This is the definition of f of x. F of x is equal to minus x. F of x is equal to 0. F of x is equal to x. This is the definition of this. Now in this, do you have a minimum value or not? We'll check. See here, when you define, let us say minus x, for fx is equal to minus of x, that means whenever x is negative, minus of minus. For x less than 0, say for example -1 you take, then what value you will get? Minus of -1. That is one which is greater than 0. Then f of x is equal to x you take. For x greater than 0, take say 1. Then here 1 will come which is also greater than 0. Followed or not? At x is equal to 0, f of x is equal to 0. So therefore, there is only minimum, no maximum. like previous sum. Only one important point is there between the previous sum and this one. In the previous sum, x is differentiable at origin. Here, in this case, x is not differentiable. Here, x is not differentiable. Why? Answer is x is defined sharply here. It is a sharp definition for x. Whereas here, the curve is smoothly defined. When in any other class, I will explain this because it takes little time. I may have to work out. I'll work out and give you as to why this is called smooth curve, why that is not so. So if you take the arguments, you'll understand. That time I'll draw a table and show you very clearly as to why this is sharply defined and not differentiable at origin, whereas that is one. That one we can define very clearly at origin, and the differentiable, it is differentiable. Here it is not. That's the only difference. Okay. So here also there is only minimum value. Let us do the third sum. Find maxima and minima for this also. What is the sum? F of x is equal to x cube minus 3x plus 3. So now here, first f dash x will find out. 3x square minus 3. So 3 take out common. X square minus 1. This you can further write x minus 1, x plus 1. Now put f dash x is equal to 0. What for? To obtain critical points. To obtain critical points. Critical points are the only points on the curve. If let us say curve is like this, then this is one critical point. This is one critical point. Maximum, minimum, these are all called as critical points of the function. So f dash x is equal to 0 if you equate, you will be getting x is equal to 1 or x is equal to minus 1 because x minus 1 is equal to 0. Here x plus 1 is equal to 0. Okay, in these cases, one value came plus 1, another value came minus 1. At each of these values, we have to find out whether the function is increasing or having a maximum at this critical point or a minimum. For that, let us take the first critical point. Let us I have taken which one? 1 I will take. First I will take 1. Next I will take minus 1. So around this one neighborhood, I will check. So here I will be checking before 1, less than 1 means 0.9 I will take. Here I will take 1.1 and I will study f dash x. What is f dash x for me? 3 into x minus 1 into x plus 1. So f dash 0.9, let us substitute 3 into 0.9 minus 1 into 0.9 plus 1. So this will become 3 open the bracket 0.1. Here 1.9. So all these put together 5.7, 0.57 I can write, no? 0.1 into 1.9 multiplication will give you 19, 1.9, 0.057 or you can write here. By 1.9, 0.019, 0.19 into 3, 0.57 greater than 0. Just you check this multiplication, but however, we are getting positive sign. F dash 0.9 came greater than 0. Next, that means the left hand side, f dash x greater than 0. Now let us go to the right hand side. 1.1 will substitute. F dash 1.1. What is our equation f dash x? 3x minus 1 x plus 1. 3 into x minus 1 into x plus 1. So let us substitute here 1.1 minus 1, 1.1 plus 1. So 1.1 minus 1 means it is 0.1 here, 1.1 plus 1, that is 2.1. So roughly this will become 6.3, 0.63. Thus, this also came greater than 0. So here also we can write f dash x greater than 0. That means when we traveled near the neighborhood of 1, 0.9 and 1.1, when the critical point is 1 here, what happened? Sign of f dash x greater than 0 both cases. So critical point 1, x is equal to 1 is point of inflection, because sign of f dash x did not change. Let us study the second point. What is our second point? X is equal to -1. So around this -1, minus 0.9. Left hand side will become minus 1.1. Minus 1.1 minus 0.9. That means what I'm doing, -1 plus 0.1 minus 1 minus 0.1, just 0.1 separation I have taken. -1 minus 0.1 will become minus 1.1. -1 plus 0.1 will become 0.9. Okay. So now let us study f of minus 1.1. F dash of minus 1.1. So 3 into minus 1.1 minus 1 minus 1.1 plus 1. So we are substituting in this equation. Our equation is same. So here 3, open the bracket, minus 0.1, and this one 1.1, yeah, minus 0.1 minus 1.1 plus 1. This is also coming to be same, no? One second, minus 1.1 minus 1. Here minus 1, 0.9. Sorry, this one small error. This is not, yeah, minus 1 minus 0.9 no, we are right only, no, previous, just 1 second, I'm correcting this. Yeah, minus 1.1 minus 1, next minus 1.1 plus 1, correct. So minus 1.1 minus 1 will give me minus 0.1. This one minus 1 minus, see here, both minus 1.1 minus 1, both are minus sign. This will become minus 2.1. Minus 2.1. This will become minus 0.1. So here minus into minus will become plus. This will become 6.3. You can write on 0.63 greater than 0. So that means f dash x here greater than 0, this side. Now we will substitute 0.9. Okay, 3 into minus 0.9. Yeah, 3 into x minus 1, x plus 1. That is the equation. Minus 1.1. We have substituted in the place of x. Now we have to substitute minus 0.9 is equal to 3 into minus 0.9 minus 1 minus 0.9 plus 1. So here minus 0.9 means this is 0.1. Here this is becoming 0.1. 1 minus 0.9. Here this is minus 1.9. This value both are minus sign. So this will become minus of 1.9. So that means 557. This is minus sign. So less than 0. That means what? As we moved around the neighborhood of minus 1 plus 1 minus 1, correct. First one what we checked, that is plus 1. Yeah, first one is plus 1, second one is minus 1. So that time what happened? Our f dash x is first time it is greater than 0, second time it is less than 0. Therefore, at minus 1 we have, see, f dash x is increasing greater than and it is becoming less after crossing the minus 1. Therefore, at minus 1 we have maxima. We have maxima. So therefore, f of x has maxima at minus 1 and point of inflection at x is equal to 1. So at minus 1, 1 both we studied now. At 1 what happened? Because sign did not change. Both the signs became greater than 0, greater than 0. For f dash x, we said that it is a point of inflection, x is equal to 1. Whereas minus 1 became maximum point. Okay. So next, last sum we'll do now. F of x is equal to x cube minus 6x square plus 6x plus 5. So here first f dash x we will do 3x square minus 12x plus 6. So 3 open the bracket, x square minus 2x plus 2, 3x plus, here minus 4 is coming now, x square minus 4x plus 2. Yeah, 3 into x square minus, when you divide, take out the common, minus 6x square, correct. So f dash x will be equal to 0. Then x square minus 4x plus 2 is equal to 0. I think this sum 2x cube. 2x cube is there here. So when you write 2x cube here, it is becoming 6x square. Small error is there here. So when I'm differentiating 6x square minus 12x plus 6. So now if you take out 6 common from here, if you take out 6 common, like this will come. This is nothing but, okay. So now f dash x is equal to 0 will give you x minus 1 whole square is equal to x is equal to 1. So we'll check at x is equal to 1. X is equal to 1 is critical point. So we want to study here whether it is having a maxima or a minima. For that what we do? Around the neighborhood we'll check this. Around neighborhood of x is equal to 1, check for maxima or minima. So we'll take a line like this. Critical point is 1. This side 1.1 you reduce. Here 0.1 you increase. 1.1. Here 0.9. Okay. So we'll check both sides. So f dash 0.9. 6 into 0.9 minus 1 whole square. So here, without any doubt, we can tell this is greater than 0. Then f dash 1.1. This is also always greater than 0. That means both sides we are having f dash x greater than 0. When x is equal to 1, when we substituted in our f dash x, we found that f dash x is not changing the sign. Therefore, x is equal to 1 is point of inflection. Okay. So it is not changing the sign. Therefore, it is a point of inflection. So friends, I will stop here. In the next class, we will try to do some sums based on this maxima minima, and then we will conclude this maxima minima chapter with that. Okay. Keep practicing the sums. All are very easy sums. All are very, very easy. Okay. Thank you.